Welcome to Economics Trainer. This video was made to help you strengthen your skills in microeconomics. Here we have a sample question, care of brighttutoring.ca. It's the kind of question you'd expect to see on a test in a first-year microeconomics class. Let's work through it together. So here's the question. Suppose we have a consumer with a Cobb-Douglas utility function where utility equals x to the exponent 0.1 times y to the exponent 0.9, which gives them the margin utilities of mux equals 0.1, x to the negative 0.9 times y to the 0.9, and the marginal utility of y equal to 0.9 x to the 0.1 times y to the negative 0.1. With those preferences, we have to figure out what the consumer would do if they have an income of $100 to purchase goods X and Y. In the question here, we have to find their optimal bundles when the price of X is 2 and the price of Y is 9. So to solve this question, we'll have to find two numbers, which we'll need two equations for. So here we have all the numbers with the setup. Let's draw out the consumer's budget constraint here. So we have good X and good Y. So here's our budget constraint. And we can see from the budget with their income for good X, this is going to be I divided by px, which is their real income for x. So we can see over here, this will be 100 divided by 2, which is 50, as the maximum amount of x they can afford over here. And then maximum of y here is going to be 100 over 9. Let's see, what's that equal to? Okay, that's roughly 11 then. So they can afford everything in here, and then their optimal bundle is going to be wherever their indifference curve touches that budget constraint. That's going to give you the optimal bundle here, x star and y star. So let's find this out mathematically by using this graph here. We can see we have the tangency condition, the two lines touches, so they have the same slope. So we have the slope of the indifference curve, mux divided by muy in its absolute value form equals the slope of this, which is negative px over py. So we just have px over py. They're equal to each other. And then we can plug in what we have here. So let's see, for the margin utility of x, plug this in on top here. It's that equation. And then on the bottom, let's plug in the marginal equation here for muy. And then on the right-hand side, let's see, px and py, that's going to be 2 over 9. So to solve out this mess here, we just line everything up vertically. So we see here with the constants in front, we have 0.1 over 0.9, so that's just over 9, or 1 over 9. And then in terms of x, we have x to the negative 0.9, and then divided by x to the 0.1. So we subtract the exponents, and we get x to the negative 1. That's the same as having x on the bottom. And then in terms of y, let's see, we have 0.9 and then minus 0.1, so that'll be positive 1, so it'll just be a y on the top. And then that's going to equal 2 over 9. Let's see here, we can get rid of the 9s on each side, and then let's move the x over. So here you get y equals 2x. So that's the first equation we need, which is the tangency condition, which tells these two lines are touching. And then we also know we're on the budget constraint, so we can use that equation as well. So let's go to the budget constraint, I equals pxx plus pyy. So let's see, the consumer has 100 for their income. It costs 2 for X. And then it costs 9 for Y. And now what we can do is we can combine these two equations together and say, okay, wherever we see a Y, we can just plug in 2x here. So let's see, okay, we have 100 equals 2x plus 9. And then we see, okay, there's going to be a Y here, let's plug in 2x. And then we just have one variable left over. So let's see, we have 2x plus 2 times 9, which is 18, so it'll be 20x. So what we have here is the x star is 100 divided by 20, so that's going to be 5. So the optimal consumer is going to have 5 units of X, even though they could afford up to 50. They're only going to buy 5 of them. And then in terms of Y here, we can just go back to this equation here and say, okay, Y is just 2 times X. So the Y star is going to be 10. So over here, up here, let's see in the graph, this point here is going to be 10. They'll buy 10 units, even though they could afford 11 and a bit more. And that's how you solve that question. This video is brought to you by people who like, share, and subscribe to this channel. You can also support my work by buying me a coffee.